Hey guys, how's everything going? This is JSer, who is not good at algorithms. I'm making these videos to prepare my interview. In this video, I'm going to take a look at 211, add and search word data structure design. We are required to design a data structure that supports the following two operations: add word and search word. Search word can search a little word or a regular expression containing only one alphabet or dot. Dot means any one letter. So like bad, dad, mad. Yeah, I think I've met similar questions before. It must be. I think it should be a tree, right? This tree is T-R-I. This tree a try. I don't know. I don't know how to pronounce it, but basic idea is tree. Like for we are getting all the words. We can just organize them into a tree. Like this is root, right? If there is a apple, an a apple, we should say apple, pull, right? Say there's a application, so apple here is the same, and here should be I, right? Apple and a vacation, something like this. So there's another, for example, there's another one like about, like a b, and then a, right? O, something like this. Of course, there might be some other words like bag, right? It's a G. So when we are adding word, we just search the word from root. Like for adding a new word like bus, we find B, okay, and then go to U, but there's no U, so we add a U, right? And then there's no S, we added S, and that's done. And when we're doing a search, we're doing the same. We search from the root and doing a BFS way. We push the next children, children, the next node in to a queue, and then loop through the nodes, and to see if it matches the letters, right? We search from search one by one. If we met a dot, we just push the next one. All the nodes could be possible, so they put the next round of nodes into our queue. If it is not dot, we just search for particular dot, right? Particular node, and push the children in. And there's a case that if there's a bus and there is a bus, what will the two words, but in the same tree pass, how would we define? How do we determine if there is a word or not? For a normal case, we could check if S has any children, right? If it has any children, then it is not the N. We can check if it is the N, but we cannot check if the bus like this, right? It has children. So how could you see if there is bus or not? So for this case, I think not only we need to add a children map, we also need to add a special identifier, not S. If there's a word like bus, actually it will be something like dollar. This is usually used in regular expression to as an ending identifier. We can do like this. If we have a tree like this, it means there is a bus and there is a bus, right? We add an N here. The bus, and bus. If there's no ended dollar here, it means there's only one word called bus. So things are getting clear. Let's do our implementation. Now first we need to create our node, right? The node is very simple. It has a character and had its children. Not children, I think next, right? Next is a map, right? It's a map of node. Something like this. Okay, for when we are creating a word dictionary, what do we do? We actually create a node, right? Start with, allow me to like this, is this one. Doesn't matter for the root. Okay, now we're gonna add a word. Root is declared, we'll actually get search the existence layer by layer. So I'll say the layer would be, first layer would be this root next, right? And we loop through the word. If layer has the character, what do? Like for bus, we have for B, we find the B, then we just move it to the next layer, right? He's here, so layer would be if not, for like B, it doesn't have U, okay, we can create a node, add to it, right? So layer set character, new node character. Cool. And then we move layer to the next one, right? Well, these two actually could be merged into one, so I'll rewrite it. Yeah, this would do. And at the end, the word is traversed, and the layer will be gonna be on the next one, right? Next layer. So what do? We add an ending identifier. This is very important. Set dollar. It's one is okay. Okay, so now we coming to the search. While we're doing the same, we do is the BFS way. For BFS, always remember we create a queue. So what we gonna be the initial? Well, the initial would be the next of root. Sure. The queue would be an array of map string of node. Now let's try to loop through the word. Because there might be multiple map in this queue, we need to loop through the queue, right? Okay, so let's say character equals word I. We loop through the queue. For this BFS search, I wanted to push a null as ending identifier and create a head, then head while head equals Q shift. This head is actually the the map of AB, right? Cool. So if character is dot, what does it mean? Dot means the map, like all the characters of the map would be available, would be valid. So we need to push all those in, right? And if it is only character, only one character, okay. Only if it is not that, we need to search for that character and push it in, right? Cool. If it is that, so we say for let key node of head. Remember, the head is map, so this is the character, this is the node. Okay, like this is the character, this is the node, right? So for we now dot AB will be also always valid. We need to push PP AU all in. So Q would push node, and if character is not, we will, like for A, we just push the A in, right? So Q would push for Q push head get character, right? But it might be undefined, so it will need to be checked if it is exists or not. If it has the character, then we push it into the queue. So then we can go to the next one. So this is for each word. We will go to the next possible layer, which has all the maps like BP and AU. But if the queue is empty, we could stop, right? If queue even, oh wait a minute, there is an ending, right? Like this. I think we should say if key is not ending identifier, we could push it. Remember that for a node, even if this last one, it has a map, even it is empty, it has a map containing the ending identifier, right? So if we found any word, letter, the next could not be. Now wait a minute. Get next. Push Q. We push node. Next. Yeah. Remember that it could not be empty. So if it is empty, we should break. And now, when everything is done, it might be two cases. The first one, the word is not traversed, but it's break ahead of the word. The for loop breaks before word is traversed. The other one, word is traversed, but it like the case here, there's no ending identifier. So I'll move the I out of this for loop, and then I'll say if I or not. Anyway, it will, if the queue, will the queue end at empty? Cool. Okay, this doesn't matter, I think. If the queue is empty, it means nothing is found. So it must be something in the queue, and we can search on the map to see if there is a dollar in it, right? Like, so for word, it must end at like word, and then a dollar identifier. Yeah. The queue is a map. Okay. If next map has dollar, we just return true. And then if not, return false, right? Let's try run the code. Layer has is not function, 38. Layer, this is next. This root is new node. Layer. Ah, God, this is next. Cool. Try to submit. Yeah, we're accepted, and actually, there's not so much improvement. I think this is clearly a tree. Create a node. Pay attention to. Actually, there's this node, but there's a map, and this is the children, right? We're using a map, so there's a node, there's a map, and there's another node. And this is a little complicated. Pay attention to that. Maybe children will be better. Maybe children are better. Okay, we push the next into layer and add the letters. Remember to add the ending identifier. So do the search, we do it BFS, and for each word, we will check all the map in the array. If it is a dot, we push all the next round map into the queue. If it's a specific letter, we push the map of that specific character next, right, into the queue. If the queue is empty, we break. Okay, and this is search. This is not like how to say DFS or something. It is not. We should not use queue at the outside. And then at last, if we found the word, like for find the bus, then the recursion, the for loop will stop at this layer, right? If we have bus, and oh yeah, next should be $ns, okay, or dollar itself. Like if we found this bus, so if there is something in the queue and one of them has dollar, it means we have this word, and then we return true. If not, we return false. So it's pretty straightforward. But pay attention to the detailed implementation. Well, hope this video helps. See you next time. Don't forget to follow, subscribe my channel. Hope to see you soon. Bye bye.